Hi friends, I'm Ramya. Today our topic is displacement and distance. In part 2 of motion in a straight line, I already discussed the distance, how to measure the path length, etc. Today I will explain what is displacement and distance and what is the difference between them. So, the definition of displacement is the change in position of an object. The change in position of an object is nothing but displacement. And it is a vector quantity. And distance is a scalar quantity. For vector quantity, there will be both magnitude and direction. And for a scalar quantity, there is no direction. It has only magnitude. Here, displacement is a vector quantity. It has both magnitude and direction. We can represent displacement with S. And it is the difference between final and initial position. It is the difference between displacement is the difference between final and initial position. Here xf is the final position value and xi is the initial position value, and it is nothing but change in position. Here this triangle symbol is a Greek capital letter delta. It is used in physics to represent the change in a variable. Variable means it is continuously changing, and constant means it won't change. Here, this capital letter in physics is used to represent this triangle symbol, is used to represent a change in a variable. It is also nothing but delta. If we place this delta before any variable, this is the variable. Before any variable, if you place this delta, it refers to the difference between the final value and initial value of that variable. If you place before any variable this delta, it refers to the difference between the final value and initial value of that particular variable. In simple terms, we can say that here in displacement we are quantifying the value of the change in the position. We are quantifying the value, that is we are counting the value of the change in the position. That is nothing but displacement. Let us take an example. In this pictorial representation, I will discuss that example. Here a boy is standing. He is standing at origin. This boy started his journey from A and he started his journey at A, and finally he reaches the point C. During his course of motion, he traveled, the distance is 200 meters. He started here and finally he reaches point C. This duration of course of motion, he traveled from A to C, and total distance he traveled is 200 meters. This is the distance, not displacement. I will tell how it will calculate it. Here from first he traveled from A to B. Then the distance he traveled is 80 meters. From B to, again this person is come back and passes through A, and finally he reaches C. In this back journey, he reaches first from B to A. Then again the distance is 80 meters. Then A to C. The distance is 40 meters. Here in distance we won't bother about negative sign because distance can never be negative, and it is the total path length, and it is the total path length from A to B 80 meters, and he coming backwards and he finally reaches C. In that duration from B to A again it is 80 meters because here the value is 0, and from A to C he reaches 40, he reaches C, so that value is 40 meters. So from A to B it is 80, B to A it is also 80, and A to C it is 40. If we total all these values, 80 plus 80 plus 40, we will get 200 meters. So distance can never be negative. That is why the total distance traveled by this person in this duration of time is 200 meters. Here for displacement, we have to measure the change in his position. In distance, we measure the length he traveled, and in displacement, we are measuring the change in the position during his journey. So here in this example, we will discuss how it came. Means the position, the change in position, how the displacement, how we will calculate, I will explain through this diagram. Here in first case, he traveled from A to B. At position, he is at initial position x1, which is 0 meters, 0, and he traveled from A to B. Here final position is, this will become final here from A to B. This is the initial position x1 and final position is x2 at time t1 and t2, at time t1 and t2 respectively. If boy moves from A to B, the change in time and position is, the change, I already told that the change means delta x, and displacement is nothing but change in the position of final value and initial value. Final minus initial, we will get displacement. Here the initial position is x1 and final position is x2. So change delta x2 x is equal to x2 minus x1. And time, change in time, here time is also variable and it is continuous. So change in time delta t is equal to final minus initial, t2 minus t1. So we will get 80 minus 0, change in position. Final position 80 minus initial position 0. We will get plus 80 meters. Plus 80 meters. Like this. Plus 80 meters. Displacement is a vector quantity. I already discussed that. Displacement is a vector quantity. It has only magnitude, and it has magnitude and direction. For scalar quantity, it has only magnitude but no direction. For vector quantity, it has both magnitude and direction. If we are dealing with motion along a straight line, that is one-dimensional motion, an object have two directions. For one-dimensional motion, the object have two directions. That is forward direction and backward direction in horizontal motion. If in case of vertical motion, that is also one-dimensional motion, in that the body is also moving straight line path. In that we will get upward direction and downward direction. So in one-dimensional motion, we have two directions, that is forward direction, backward direction, or upward direction or downward direction. Here from A to B, we will get the change in position, that is displacement. We will get, we got A here is 80 meters. In this second case, he moves back from B to A. Then from A to C. Here from B to A, the change in the position is, here it will become initial position, and this will become final position in this case. Before it is initial position, this is final position. Now he starts from B, that is why here we are taking initial position, and this will become final position. Here from B to A, change in time is T3. Then now this will become, position won't change, here time will change, that is it will become T3. So from the change in time is, this is the final position, this is the final time, this is the initial time. That is why we are taking final minus initial, which is nothing but displacement. Here T3 minus T2, that is the change in time. And for A to C, this will become initial position, initial time, and this will become final position and final time. So change in time is T4 minus T3. From B to A, change in position is x1 minus x2, because from B to A, this part will become, this part is final and this part is initial. So we are taking x1 minus x2, and from A to, and his position changes from x2 to x1. It will become delta x is equal to, change in displacement, delta x is equal to x1 minus x2. So it is 0 minus 80. So we will get minus 80 meters, in time T3 minus T2. Magnitude, here we are getting magnitude as 80 meters, and that negative sign indicates that it is directed towards negative x-axis, that boy is going. Here from B to A, time T3 minus T2, and A to C, T4 minus T3. B to A position, we will get minus 80 meters. And from A to C, position of the boy at C is x3. And from A to C, position of the boy at C, is x3. So he is moving from x1 to x3. So change in the position. This is the initial position, this is the final position. So according to the formula, delta x is equal to final position minus initial position. That is why this is the final here and this is the initial here. So the change in the position is x3 minus x1. Delta x is equal to minus 40 minus 0. Here that A position value is 0. So delta x is equal to x3 minus x1, that is minus 40 minus 0. So we will get minus 40 meters. Here we will get minus 40 meters. In time T4 minus T3, minus 3T from A to C. Negative sign indicates that is directed towards negative x-axis. So finally, the change in the position of the boy during his whole journey can be calculated by adding all these displacements. Finally, we will get the value of that person. Finally, when he reaches point C, we have to add total displacements. That is, in case 1, A to B, we get the displacement as 80 meters, and case 2, from B to A, minus 80 meters we will get, and from A to C, we will get minus 40 meters. The total displacement, the change in the position of that boy during his whole journey, can be calculated by adding all these displacements. That is, first case, A to B 80 meters, and from B to A minus 80 meters, and from A to C minus 40 meters. Finally, the answer is final displacement when he reaches at C. that is minus 40 meters. Here the magnitude, this is a vector quantity, it has both magnitude and direction. Both magnitude and direction. This is the unit. Here the magnitude is 40 and this sign shows that he is passing towards negative x-axis. And magnitude of displacement is always less than or equals to the total distance. Magnitude of displacement is always less than or equal to the total distance, but distance never be 0. And or simply we can measure the distance by taking initial and final positions too. Simply we can measure the distance by taking initial and final positions, and which is also nothing but the shortest distance between the initial and final positions. Displacement also, we can define displacement like this also. It is the shortest distance between the initial and final positions of the object in a particular direction. In this problem, initial position is 0 and finally he reached C. Initially he is at A and finally he reaches C. So this is the initial position and this is the final position. So according to the displacement, delta x is equal to final position minus initial position. So the final position is minus 40 minus initial position is 0. Finally we will get minus 40 meters. Like this also we can measure the displacement. And according to the difference between displacement and distance, I will show some diagrams. Here, the complete length of the path between any two points. The complete length of the path, this is the path. The complete length of the path between any two points is called distance. The complete path between any two points. This length is nothing but distance. This length is nothing but distance. This complete length is nothing but distance. And here it is the direct length. Displacement is the direct length between any two points and also shortest length. It is the direct length between points A and B, which is also the shortest distance between them. Shortest distance between them, which is nothing but displacement. And this is also distance, and this shortest distance is the displacement. And distance is a scalar quantity. Here it depends only on magnitude and not in direction. And displacement is a vector quantity. It has both magnitude and direction. And distance can be measured in a long path, in any long path. Here also we are taking long path as distance. This long path as distance, which may be straight or any curved path. It depends on, distance depends on path. Distance depends on path it followed. And while displacement can only be measured along a straight path, displacement can only be measured along a straight path. It does not depend on the path. It depends only on the initial and final position. Displacement only depends on the initial and final position. It does not depend on the path. It is the shortest distance. And distance does not decrease with time. Distance does not decrease with time, while displacement can decrease with time. In the previous example also, here time is increasing. Here T1, T2 time, while it coming from B to A, it time increases T3, and here T4 time. A to C time will become T4, but the displacement, that is change in the position, that value here decreased, which is nothing but displacement can decrease with time, while distance cannot decrease or does not decrease with time. So according to the formula, Distance is speed into time. We know that speed equal to distance by time. From this, distance is equal to speed into time and displacement is equal to velocity into time. We know that the formula velocity is equal to displacement by time. Then from this, displacement is equal to velocity into time. This is the simple difference between distance and displacement. Thanks for watching.